Hello everyone. In this session, we are going to learn how to add a caching layer for .NET applications using Amazon ElastiCache for Redis. My name is Srivan Tattanayaka, and I'm a Senior Partner Solution Architect at Amazon, focusing around Microsoft technologies. We will first learn why we need caching by going through some use cases, and then learn about Amazon ElastiCache. We will then focus on how to create an Amazon ElastiCache cluster for Redis and learn how to use it in our .NET applications. Why we need caching? Imagine you are doing an expensive read operation from a data store that takes a lot of time. If you can store the result in a cache, when you query for the same dataset later, you can access it quickly, reducing the latency, increasing the speed, and more importantly, reducing the load in the data store. In this example, when the application sees a cache miss, it reads from the data store, store the result in a cache. When you access the data next time, you can access the data directly from the cache. What I discussed before is only one use case. There are many such use cases. For example, in gaming industry, we use caching for player leaderboards, and in machine learning, we use caching to store pre-calculated models. At Amazon, we don't believe in one-size-fits-all databases. Developers are now building highly distributed applications using multitude of purposely built databases. Developers are doing what they do best, breaking the complex applications into small pieces and then picking the best tool to solve each problem. If you are looking for a fast, low latency in-memory cache solution for your .NET application, Amazon ElastiCache is a great place to start with. Amazon ElastiCache is a fully managed, highly available, secure and reliable low latency in-memory caching solution based out of time-proven open source technologies. It comes in two flavors, Memcached and Redis. In this session, we will focus on Amazon ElastiCache for Redis. Let's now go for a demo and then learn how to program for Amazon ElastiCache for Redis using our favorite .NET languages. Let's go for ElastiCache section of the AWS console. Before we create a cluster, let's first create a subnet group. Our cluster will be deployed into the subnet group to the given availability zones. Let's now create a Redis cluster. Select the cluster engine as Redis, give it a name, a description, an engine version, and the port number. In this case, I'm going to select the node type as T3 medium because I don't have a lot of data. Number of replicas as 2, enable multi-AZ, subnet groups, I'm going to select the subnet group I created a moment ago. And for availability zones, I'm going to put my primary and the read replicas in these given availability zones. You can import data from an S3 bucket. These are all Redis features. You can enable backup, leave them as default, and let's create the cluster. It will take some time for the cluster to come alive. Meanwhile, let's go there and then start programming. I'm in my Visual Studio. I have added a NuGet library called Stack Exchange Redis. This is the same library the Stack Exchange use in websites like Stack Overflow to read in their Redis clusters. Amazon ElastiCache for Redis use the same protocol the open source Redis uses, so you can use any of these Redis available libraries to read from Amazon ElastiCache for Redis. I chose Stack Exchange Redis because that's the most widely used one, and I have added that one into my NuGet packages. It also adds a few more dependency libraries. I'll leave them as it is. Back in my program, I have defined two endpoints, primary endpoint and read endpoint. Primary endpoints is the one that you use to either read or write. Read endpoints can only be used to read. You can find these endpoints in your Redis cluster. So these nodes are available. You don't directly connect into these nodes. Instead, you use the primary endpoint and read endpoint given here. So primary endpoints for read and write, read endpoints for read operations, If you clearly know which endpoint to use for writing, use for primary endpoint, you cannot write into read endpoints. Back in my Visual Studio, I have defined my primary endpoint and my read endpoint, and then going to create a class called connection multiplexer and given these two endpoints. You can include any number of Redis endpoints or nodes here, but the proper way to do this one is to only give the primary endpoint and the read endpoint. You only keep a singleton instance of this connection multiplexer. Although it's a disposable object, you are not going to dispose it every now and then, but this is an example, therefore I just keep it. I also create a database by calling Redis get database. That will return a database which I can later use to do some operations. And I use a db string set to set a value called my value with the key my key and set the timeout as 600 seconds. And you can also define how to set this object. So always make sure if there's no object, it will update it. If there's an object, it will update it. Exist will set the value if only object exists. Not exist means that it will only update if there's no such object. The default value is always, you can leave it as it is. And also you can specify the command flag, which specify which node you prefer. Of course, this is write operations because I'm going to set the string. So in this case, I want to have the master as my preferred node. This is not a mandatory one. You can ignore it and the db set string will automatically identify it. But in this case, I'm specifying master as my node. So when I run it, I set the string and I can now read the value. If you read the value, you can see the value is now my value. If you use the wrong command flag, so let's say in this write operation, I use demand replica, which is for read only operations, it will throw an exception. So here, if I continue, it will throw an exception. So ideally, you don't need to specify the command flag. You can let the connection multiplexer to manage it. So in this case, I'm just going to set the key and the value along with how long I want to keep this object. And in this case, I can easily write it. And when I read the value, I get the correct value that I saved. Redis provides complex data operation that includes publisher and subscriber model, where the publisher published to a given channel and all the subscribers can listen to that and get that message. I created two console applications. One is called my Redis publisher. The other one is called my Redis subscriber. So in the publisher, creation of the connection multiplexer is same as before. I get this interface called iSubscriber and then publish a message called hello to a channel called messages. I have a subscriber called my Redis subscriber. Connection multiplexing is same as before. I get a name for subscriber and I then listen on the channel messages, and whenever a message arrives, I print it into the console along with the subscriber name. I also have a read line to make sure that the program won't terminate. Let's start a few instances of subscriber. For the first one, let's call sub1. And let's start another instance called sub2. And let's start the third one called sub3. So these are all subscribers now listening to the channel called messages. And let's now run the publisher, which will write a message called hello. You can see that all the subscribers receive that message. When you run it again, they got that message almost in real time.